Assalamu alaikum wa rahmatullahi wa barakatuh. I'm here to share this video with you on software design, which talks about software design activities and how the design of software should be. In a journal, Dr. Dobbs, Mitch Capo, the creator of Lattice 123, presented software design manifesto that should include, or a software or a good design should exhibit three things. One is firmness, second, commodity, and last is delight. The firmness has to do with the behavior of program in such a way that no bugs should protect or should prevent this kind of program to continue with its intended function. And second, for the commodity, is that the program should be suitable enough and it is trying to exhibit the purposes for which it was intended. Then delight, it means that the experience of using the program should be in such a way that is pleasurable one. So here in a nutshell, software design encompasses the set of principles, concepts, and practices that lead to development of high-quality system or product. In this case, design principles establish an overriding philosophy that guides the designer as the work is performed. This point is trying to express that while the design processes is taking place, the life cycle of software design is in such a way that if new things come, the philosophy will guide you to adopt the new design so that the old one is overridden. Next point is design concept must be understood before the mechanics of design practice are applied. It is always obvious that we need to understand, we should understand the problem. So in this case, we have to understand the design principle before we apply any design. So software design practices change continuously as new methods, better analysis, and broader understanding evolves. So software engineering design. In software engineering design, we have the following. We have data or class design, which transform analysis classes into implementation classes and data structure. And we have architectural design. This design defines relationships among the major software structural elements. There is interface design, which defines how software elements like hardware elements and end user communicate. We have component level design. This transforms structural element into procedural description of software components. So as we can see from our analysis model discussed earlier, it is we have a bridge that takes us to design models. So all of the four analysis model, that is scenario based elements, flow-oriented elements, class-based elements, behavioral elements, they are mapped to different parts of design models, as you can see. So here is like class-based elements is mapped to data class design, architectural design, as well as component level design. Same thing with scenario-based element is mapped only to interface design. As you can see, flow-oriented elements, it has three maps, which is to component design level, and interface design level, and architectural design level. Same thing with behavioral is mapped to two, which is component level and interface level. So design and quality. A design or the design of software must implement all the explicit requirements contained in the analysis models. because in the analysis models, after the requirements have been undergone different stages of processes, then we have the explicit requirement, which is believed is a kind of complete requirement in the analysis model, and it must also accommodate all of the implicit requirements desired by the customer. Then another thing is design must be readable, understandable guide for those who generate code and for those who test and subsequently support the software. Design should also provide a complete picture of the software, that is addressing the data, functional, behavioral domains from an implementation perspective. So to go for software design, we need to understand and apply and adhere to certain quality guidelines, because one of the primary intent of our design is to ensure quality. It's the fundamentals for ensuring the quality of software development. So design should exhibit an architecture that is, one, has been created using recognizable architectural style or patterns, and is composed of components that exhibit good design characteristics and can be implemented in an evolutionary fashion. Another quality guideline is a design should be modular, that is, the software should be logically partitioned into elements or subsystems. This makes things easier and simpler. So a design should contain distinct representation of data, architectural interfaces, and the components. A design should lead to data structures that are appropriate for the classes to be implemented and are drawn from recognizable data patterns. A design should lead to components that exhibit independent functional characteristics. A design should lead to interfaces that reduce the complexity of connections between components and with the external environment. A design should also be derived using a repeatable method that is driven by information obtained during software requirement analysis. Design should also be represented using a notation that effectively communicates its meaning. So, beside design guidelines, we also have underlying principles of design. These are: design process should not suffer from eternal vision. Design should be traceable to the analysis model, and design should not reinvent the wheel. Design should minimize intellectual distance between the software and the problem as exists in the real world. Design should exhibit uniformity and integration. Design should be structured to accommodate change. Design should be structured to degrade gently, even when aberrant data, events, or operating conditions are encountered. Design is not coding. As such, coding is also not a design. Design should be assessed for quality as being created, not after the fact. Design should be reviewed to minimize conceptual errors. So, these are the fundamental concepts of design. Each design has this concept. One is abstraction. It is very important to understand this kind of concepts because they are the underlying concepts that build up a design. So we have abstraction that has to do with data, procedure, control. Usually abstractions is a kind of information which is implicit to the user, because a certain information that is not useful to the user is hidden. So we don't need to sometimes understand actually the internal processes or the internal structure of something. So it has to do with abstraction. We have architecture, the overall structure of the software. We have different structure at different level, and we have patterns which conveys the essence of problem design solutions. Usually patterns help in solving recurring problems, separation of concerns. It has to do with a complex problem which can be more easily handled if it is subdivided into pieces. So we have modularity, which is compartmentalization of data and functions. We have hiding or information hiding, which is a kind of controlling the interfaces. Information or data that is inside a particular component is protected against unauthorized access. Or then we have functional independence, single-minded functions, and low coupling. We have refinement, which elaborate details of all abstractions. So in this case, when information is hidden or is not explicitly described in the abstractions, in this refinement is a kind of elaboration of those kind of details that are put or that are not explained well in the abstractions. Then we have aspect, a kind of a mechanism for understanding how global requirements affect designs. And we have refactoring, which is a reorganization technique that simplifies the design. Then we have object-oriented design, which is explained in Appendix 2 for those who are interested to learn or to know more about object-oriented concepts. Then we have design class. Design classes also provide design details that will enable analysis classes to be implemented. So this is the end of this video. So thank you for listening. We meet inshallah in the next video show. Thank you.